Hello and welcome back. Here's the Yamaha C1 preamplifier all taken apart. As you could see, there's a large number of components this unit has inside, which is probably a deterrent. That's why not a lot of people want to service this unit. Outside the fact that it has a lot of very unique components. As far as the repair of this particular unit, this does qualify for one of those worst case scenarios. I was hoping for an easy fix. It didn't get lucky. Before I get into the nitty gritty, I'll just want to walk you through the give you a high level overview of each one of the boards. And obviously here's the chassis. The chassis is all stripped of all these boards. It's just a transformer basically. There's nothing on this other side. There's some Mickey Mouse boards in the back there for the pots, which I still have to clean. The power supply board has been extensively built. All new semiconductors, all new electrolytic capacitors, new trim pots. I raised the heat sinks. I don't know if you could see. I raised the heat sinks of the low voltage regulators. Transistors because they're scorching the PCB. There's no need for that on the high voltage regulators. Obviously this board gets really hot. Oh, there are a couple of resistors there which also scorched the board, and I raised up and I used good quality V-fet low noise resistors. You could see there's an insulation cardboard underneath. Yamaha used like transformer paper, and it got pretty scorched up and deformed. I replaced this with Nomex with aramid paper. This is this is good up to 200 degrees Celsius, 400 degrees, about 400 degrees Fahrenheit, or gotta look up the conversion, but it basically will never get to this condition ever, so much better than the original. Alright, moving along here. Here are a couple of small boards. This is the tape buffer. This is the ping noise generator. I replaced a bunch of capacitors on these boards. Moving along farther, this is the tone control board, which I will get to in a minute, and that is the phono section. The phono, there are two amplifiers there, the phono amplifiers. I'll get to those in a minute too. This is the main selector board. I replaced this relay already. All this have been cleaned. All these inserts have been taken out and cleaned manually. Placed a couple of capacitors and two resistors here. With the power resistors were touching the board again. I raised them up and used non-inductive resistors there. Also V-fet. This other selector here, this push button selectors, these have also been taken apart and individually cleaned throughout. Obviously tested each contact afterwards to make sure there are no resistance. Same thing with the toggle switches here. This all have been taken apart and cleaned, like individual taken out of the boards. Obviously all these boards have been cleaned altogether, all the wax removed, all solder joints reworked, and yeah, every single one of them has been cleaned up. Same thing with this step attenuators here. These are for this is for the lows, this is for the highs, and this is for the presence control. This is all on the tone control board. If you notice, Yamaha uses 4 gangs attenuators. Same for the main. Actually, this is 5, but one is a dummy. The reason is they attenuate both input and output for each one of the boards, which is you know, just speaks to the quality of the unit and the attention to the details that Yamaha paid out. You know, just want to make sure that they don't transfer any noise to anything else when they're attenuating a signal or they're equalizing a signal. I didn't get to this right here. I didn't clean this yet. The 2 relays I need to replace. This I did clean, taken all this and clean, and this has all been cleaned up, all the capacitor replaced. This is for this little potentiometer here is for the headphones. This is the balance This right here, this other board is, this board is for the phono 1, phono 2. Phono 3 is a straight through path. Phono 1, phono 2 gives you the option in the C1 to change the impedance. Alright, this is another important board. This is the main buffer of the amplifier. This, you could see the where I mentioned that in the earlier video that this scorched the resistors here scorched the board. I replaced this with Bishadale non-inductive resistors there. All semiconductors replaced here, all capacitors replaced. In this section here, it is the this is the headphone amplifier, and here I've done some a few more upgrades. Actually, this should sound pretty well right now. This right here, it's the oscillator board. Sits inside this shielding right here. That's removed right now for servicing. All capacitors I replaced. I'm not going to replace the trim pots, they're pretty good. This is a voltmeter board. I haven't replaced anything yet except a couple of tantalum capacitors which I found to be leaky, and I would make that voltmeter act really weird after a unit warm up for a little bit. So I have, they were leaky obviously. I still gotta clean this. It's cleaner than other boards, but it's still got a lot of wax in it. And then cleaned it. The switches are clean actually. I cleaned those. I need to clean them anymore. Alright, so now what was wrong with this unit? So initially I found out that the right channel on the tone control board was non-responsive. You know, the unit would play fine if the equalizer control, the tone controls, were bypassed. You know, played on both channels. If I used an input from like an auxiliary input, the preamp would work fine. As soon as you flip the switch and turn on the tone control, the right channel will go out. And this was actually an easy fix. It wasn't a switch as I thought it was a switch. It was not a switch. That's why probably the prior tech couldn't basically just spray the oxy there and then fix it. It was this connector, so I replaced it. As I mentioned, there are a bunch of connectors that are susceptible to failure. So so far this is the only one that I found that's bad in the amplifier. You know, there are usually other ones that are bad, but this one is the one that I found bad, and I replaced. I like to use the little like just like the ones they use in the Arduinos that are gold pin plated. They are also 2.54 millimeters distance, so they are just like the original. You can see on original there. And I used an angle one here because it's just sits better on the angle. You'll see when I'll show you this at the end. Well, it's going to be all back up. Obviously, this board I replaced this 47 microfarads bipolar capacitors. I use Nishcom use throughout it. By the way, if you're ever doing one of these units, just take a look how many green capacitors are here. Might as well just buy an entire bag of capacitors. I buy like 100 at a time. You know, that lasts me for a couple of years, maybe three of the C1s. Yeah, it's quite a bit of them. But yeah, so that was the surface of the problem this unit has. That was relatively easy. It was hard to spot though, because it took me a while to figure out that there was a problem. But the major issue was with this phono amplifier board, and this was the left channel that was out. So as I would switch inputs and use the phono for input, then it doesn't matter tone control, no tone control, there was nothing coming out of the left channel. And the reason is, well, the worst case scenario happened is I had two fried out V-fets, this two right here, a 2SK78 and a 2SJ24, and this was not a good position to be in. I only had a replacement for this 2SK78, and for the 2SJ24 I had to pillage one from, actually I had to change both, but I had to pillage them from a B1 driver board. They're rank A, so they're the same rank, so they work just as the originals. But yeah, not a good situation to be in. Here are the culprits. This is the 78. This is the 24. I did find, here's the connector. Here are the two bad 10-tone capacitors from that. The only thing that I found wrong in this board, besides these two V-fets, or these two caps, these two resistors are still good, but they took a lot of heat. They've been discolored, so I replaced them with half watt and resistors, and I raised them up off the board a little bit. One curious thing though, and I don't think these things could have caused the failure, not this capacitor, but look at this little capacitor, how it tests in the nanofarads right now. It's all vented, gone. This one didn't vent, but it's also in the nanofarads. They are part of that left channel, and I didn't find anything like these, like this on the right channel, which worked. So the left channel, that was bad. I did find these capacitors, but they are not necessarily, I mean, I don't know if they would have caused this. So let's just take a quick peek at the schematic. So if we look at a schematic, so these are the two transistors that were bad, this guy and this guy. And the only thing that I see they have in common is their gate source comes from this voltage divider here, this resistors, but none of those resistors are bad. They all test perfectly. Maybe I should replace them anyways. What the hell? Maybe I'll go back in there and replace them. I don't know what caused these two transistors to fail, and this seems to be the only thing that they have in common here in terms of circuit. This is where the bad capacitor was, one here and one right here. I mean, I don't think they would have impacted this two V-fets, so I can't really tell. I tried to look at a retrospective, and I'm still digging into trying to figure out why this would have failed. So the bottom line is they're dead and needed to be replaced, and they are not something you just find off your Mauser or DGK or somewhere else. So that said, when I will return next, this unit should be put back together. I'll finish off the rest of the touch-ups that I wanted to finish up, and we'll talk to you soon.